Good day, ma'am. My name is Garcia Bjorn. The topic that I'm about to discuss is measures of relative position or quantiles for ungrouped data. Measures of relative position ungrouped data. There are three: quartiles, quartiles, deciles, and percentiles. For quartiles, divide the distribution into four groups. So each subgroups in quartiles is equivalent to 25%. Deciles. Divide the distribution into 10 subgroups. Each subgroups in deciles is equivalent to 10%. Percentiles. Divide the distribution into 100 subgroups. So each subgroup in percentiles is equivalent to 1%. Quartiles. The parts of quartiles are Q sub 1, Q sub 2, and Q sub 3. For Q sub 1, it is the medium value of the first half of the distribution or the lower half of the distribution. Q sub 2 is the median value of the distribution or it is the median value of the whole data. Q sub 3 is the median value of the second half of the distribution or the upper half of the distribution. Each quartile is equivalent to 25%. Deciles. Deciles are measures of position calculated on a set of data. Deciles are the values that separate a distribution into 10 equal parts where each part contains the same number of observations. The formula for deciles is d sub x wherein d sub x is equal to n plus 1 multiplied by x over 10, wherein n is the number where n is the total number of values and x is the decile that is being asked. Percentiles. Percentiles denoted by p sub k are measures of relative positions that divide the distribution into 100 parts. Percentiles is a comparison score between a particular score and the scores of the rest of the group. The formula for percentiles is number of values below x plus 0.5 over the total number of values multiplied by x, wherein x here is the percentile that is being asked or the rank of the percent value that is being asked. Example for percentiles. A 40-point contest was given to 10 students and the scores are shown below. What is the percentile rank of 30? The scores are 19, 24, 31, 30, 26, 22, 20, 15, and 20, 29, and 23, and 33 rather. Now, for the solution, first we need to arrange the data in an ascending order. So 15, 19, 20, 22, 24, 26, 29, 30, 31, and 33. Now we know that the formula for getting the percentile rank is number of values below x plus 0.5 over 10 multiplied by 100. So we know that as we have arranged the data in ascending order, we know that now we can count how many scores or values there are below x. So 1, 2, 3, 4, 5, 6, and 7. So 7 plus 0.5 over 10 multiplied by 100 is equal to 75 percentile. This means that a student with a score of 30 did better than 75% than the other students. Another example. The following list of scores resulting from the competition event administered to 15 candidates. What is the percentile rank of 45? So the values are 20, 33, 55, 64, 47, 45, 62, 28, 40, 58, 23, 35, 60, 30, and 37. Now, first we need to arrange the data in ascending order. So 20, 23, 28, 30, 33, 35, 37, 40, 45, 47, 55, 58, 60, 62, and 64. So we need to locate the 45 and count how many scores or values below it. So 45 is here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 0.5 over the total number of values, which is 15, multiplied by 100 is equal to 56.67 percentile. This means that a candidate with a score of 45 did better than 56.67% than the other candidates. Now, example for quartiles. Find the value of Q sub 2 of the following grades of the students in mathematics in the modern world subject. Now, here are the grades of the students. 79, 88, 96, 92, 83, 90, 81, 85, 75, and 86. Now, we need to arrange the data in ascending order to determine the median. 75, 79, 81, 83, 85, 86, 88, 90, 92, and 96. Now, we know that Q sub 2 or the value of Q sub 2 is the median of the entire data distribution. Now, as we can see, there are two values in the middle. Now, we add those two values, which are 85 and 86, and divide it by 2. And the value of it is 85.5. This means that 50% of the students get a grade of 85 or less. Another example. The following are the scores of students from an exam. Find the value of Q sub 1 and Q sub 3. The scores of the students are 24, 32, 41, 35, 20, 28, 30, 47, and 45. Now let's arrange it in ascending order. 20, 24, 28, 30, 32, 35, 41, 45, and 47. Now, we know that we can find the median here, which is Q sub 2, to determine the lower half of the first half of the distribution, which is the value, the Q sub 1, the upper half, which is the consists of Q sub 3. So we know that the median here, or the Q sub 2, is 32. So now we know that 20 to 30, 20, 20, 24, 28, 30 are the first half of the distribution, and we know that we can see that there are two values here that are the median of the first half. So we add them together and divide it into, which are 24, 28 over 2. It is equivalent to 26. So this means that 25% of the students get a score of 26 or below. For Q sub 3, the median is 41 and 45. So we add those two, 41 plus 45 over 2, which is, the value is 43. So this means that 75% of the students get a score of 43 or below. Now, an example for deciles. Find the D sub 5 of the following set of data. 19, 12, 16, 0, 14, 9, 6, 1, 12, 13, 10, 9, 7, 5, and 8. Now let's arrange it in ascending order. 0, 1, 5, 6, 7, 8, 9, 10, 12, 12, 13, 14, 16, 19, and 19. Now we know that the formula for decels is d sub x is equal to n plus 1 multiplied by x over 10. And our x here is 5, or it is d sub 5. So, and our n here is 15 because the values, total number of values is equivalent to 15. So, d sub 5 is equal to 15 plus 1 multiplied by 5 over 10 is equal to 8. So we know that the value of d sub 5 is in the eighth. So we count 1, 2, 3, 4, 5, 6, 7, 8. So the value of d sub 5 is equals to 10. Thank you, ma'am.